Can we do these kind of models also for other things? One of the stuff we would like to do is, let's look into the cross. Alice and Bob was easy, but what is, for example, with the cross? If you have symmetric traffic and you have the cross, what will happen? Alice and Dave here, they're exchanging something. Charlie and Bob are doing the same. So what you will see is all the outer nodes will send something, the others will stay idle, and the relay will just receive them and later spit them out again. And this means we need 8 time slots if you do this in store and forward. But as I told you, when the load becomes larger, very large, then the relay is not allowed to send out more than the others. So this means the low load scenario, right? Until we did not reach the capacity of the channel. But when we reach the capacity, then you see everybody can send only one packet. So the outer one's filling the relay, and the relay is only forwarding one packet, which means that 75% of the traffic will not arrive at its target. How can network help there? So first is, if we do XOR, how can we do that? We can do it per flow. This means without overhearing. That means Alice and here we send the outer node send again, and now the relay will take the one of A and D coded together and broadcast it, and then B and C and broadcast it. This means we only need 6 here, but in the case that we load up the channel, also the relay can only send 1. Could be this one or could be the other one, I don't care. But here only 50% will reach the target. Good. So what we can do now is to say, okay, let's do overhearing. Overhearing means if A sends to the relay, B and C can overhear it, but not D, who originally should have it. Now you see that there's always one guy idle, and then in the end the relay will send out one coded packet. If you do that, you see it's always 5 packets. It doesn't matter, low load, high load, it's always the same. So if we then look at the same plot that you have seen before, the same characteristics, we get our throughput over load. And all of them start at the same point, right? We are increasing the load from the 4 outer nodes, and then we go down. Here, the first point, after 50%, we go down and stabilize here. That's exactly what we saw in the Catwoman example, right? So 50%, which means 12.5% from all the nodes, then the relay will send something. Here it will drop. Therefore, I said this is the first plot, everything fine, and then with this, we will go down. So in this phase, he can send more, the relay can send more than 1. Maybe 2, right? He can still send 2, 2.5, 1.5, what something, 0.5 over here. So the other one where we take where we use an XOR in the same flows, what we will see is we go up, way better than this point, but at a certain point we will reach this point and go down again. So what you see here is the end capacity here is 20%, here the end capacity is 40%. So what if we would code with overhearing? We try to listen to everything in the broadcast scenario. What you see is then you can go up until 80%, and then you stabilize here. Why 80? You have 5 nodes. 20% is the relay. The relay traffic is, so to speak, the payoff that you increase the coverage. And then you have 80% load here. So what you get is, this is state of the art. XOR over the flows is 3 dB gain. And there's another 3 dB gain if you do the full overhearing. So 2 things. The first 3 dB is very easy to reach, because this means I just have to do the XOR. There's no overhearing. But here I need the overhearing, which means it's vulnerable. If some of the overhearing goes wrong, then I'm doomed, and it will fail here and go a little bit lower. We show you later how to reach this point. But to say, hey, this one you should use for sure. There's not a lot of things you have to do in extra, but this one is harder to get. I think this you can do already today. The next or the last 10 lectures will just be around how we get the next 3 dB, right? There's something else you could do. It's a nice question, why you just don't have a load balancer. So if you could communicate among them, then you could say, once I reach the maximum, I stay there. I don't allow them to send more. Now in the context of software-defined networks, where you have one centralized controller, even for wireless mesh, I think that is quite an option to say, why don't we control the load? We tell the people, now it's enough, we should stabilize at this point. Nevertheless, you see, there's still gain. We get so much gain here because IEEE 8.11 is such a stupid technology. So it's very easy to heal something that is stupid. If you make it intelligent, then the coding gain will be not that high. But as we always deal with these kind of topologies, I think we can assume that this is something that we will see in the real life today, right? Okay, I would continue the next time in the next lecture explaining you a little bit more into this medium access, because we built our own system going away from the IEEE 8.02.11 and showing you also the impact of the buffer bloat, and then continue with some of the nice features that we have seen with XOR, and maybe also go to the analog stuff. So thank you very much for today.